Assalamualaikum and good day. Welcome back to my video as usual. So in the previous video I have already shown you how to construct this circuitry here for the piezo buzzer. If you have a piezo buzzer, so if you use the Tinkercad, so just choose the buzzer. Just search the buzzer in the Tinkercad, so it will comes with the piezo buzzer here and just use it. Yeah, so that's it. And for the I also have shown how to use it with the Proteus, so make sure again you choose the one that can output the sound from the sound card, and hopefully you already have construct this circuit by now, so that we can directly move to the coding. So again, if you still confused, still don't know how to find the components, everything I have shown in the previous video. So if you don't watch that video yet, please watch the video. You can click the link up top or down below. Again, don't forget to watch the previous video, because in the previous video I have also have explained a little bit on how the piezo buzzer works. If you want to know how it works, or the basic concept of the piezo buzzer and the magnetic buzzer, so everything I have already explained in the previous video. In this video I will just directly go to the coding as usual. We will directly go to the coding. So the coding for the buzzer is basically as usual. We first, to make the coding is simple, especially if you want to change the pin number later on. So make sure you just define all the pin number up here in for the buzzer, which is now is at the pin number 9. So the pin number 9, so pin number 9, so let's go to the pin number 9. So this is the pin of the buzzer. So this is the first thing, and then we goes to the void setup. So as usual, void setup, we just define the pin mode of the buzzer, which is as output, because the buzzer is given the sound. So this is output. So this is the only pass, and the new thing here is basically to generate the sound. To generate the sound, we can use tone. So tone for the buzzer. So if you don't define buzzer up here, so you just change it to the pin number here. So tone buzzer, which is the pin number, and then the frequency you want to generate. So here is, I put 1000 frequency. So 1000 frequency meaning that we generate, or we send 1 kilohertz of sound signal. So this is if we use 1000. If we want to reduce the pitch, again the sound frequency, the higher the frequency, the higher the sound pitch, the nyaring it is, bahasa Melayunya. So if you want to reduce the pitch, you want to make it sound more dimmer, then you choose lower frequency. So basically you can try to set any values here, but make sure it is not exceeding the maximum. For example, like this, in this buzzer here, the maximum here is 3.4 kilohertz. So the resonant frequency is the maximum frequency. So if you operate at the resonant frequency, it will be the loudest. So the loudest here is 3.4 kilohertz. And let's say if you want to use other buzzer with higher sound, especially with higher alarm, so you can choose it. For example, like this one here has a lot of release, but again, and also the sound pressure. So sound pressure means the sound, the maximum sound it can produce, so in decibels. So the higher the decibels mean the higher the sound it can produce. So if you want to have a higher sound, a louder sound, so you can choose the higher values here. But note that the higher the values, or the different buzzer have different rated voltage. Yeah, so meaning that if you want to use this buzzer here, you might need to change or you might need to add additional power supply to the circuit before you connect with your Arduino, or sometimes it is not even suitable for the Arduino. And again, this is how you choose which buzzer is suitable for your project. So if you want to produce a very loud sound, for example, if you want to make a car alarm system or a home monitoring system, so basically you want to have a very very loud alarm, so therefore you need to choose a higher decibel. For this frequency, for my buzzer, or the one that I use, is just up to 3.4 kilohertz, or the sound pressure level is about 80 decibels only. Yeah, so it can goes up to 3.4 kilohertz, but here I just put 1 kilohertz only, 1 kilohertz only, or 1000, because I don't want to make people around me shocked with the sound when I test it later, especially if your neighbors are sleeping near you here. So basically you need to make sure that the sound is not too high, too loud, and that's why I just choose 1000. So again, you can choose whatever value here. If you want to reduce the sound, so just reduce the number here. You can try, and then maybe after 1000, after 1 second, I just wait for 1 second, and then we can stop the value. So to stop the value, we use no tone. So tone to make a sound, no tone to stop the sound. So that's it. So this is to stop the sound, stop sound, and then maybe stop at about 1 second, and then that's it. So basically the new codes here is just these two, tone and no tone, tone and no tone. Tone to make it sound, no tone to stop the sound. So that's it. So if you want to test this, you can test this. So let's try to test this as usual. Let's try to test this code. Okay, so now we upload the codes. So upload the codes. So let's try. So you can hear the sound now. So let me give the higher sound here. So this is for 1000. This is for the 1001 kilo hertz. So if you want to reduce the sound, so you can reduce the sound. If you want to increase, you can reduce the number of hertz here. If you want to increase the pitch, so you can reduce, you can increase the frequency there. You can increase the value of the frequency here. So that's it, as simple as that. So basically this is the coding for the buzzer here, but we don't want to stop here, because we want the when it detects obstacle, it sounds alarm. So how to do that? This is the coding from the previous video. It's not a new code, so if you don't watch the previous video, go and watch the previous video. If you have Arduino, if you have ultrasonic, especially if you don't have ultrasonic, then you can stop here. You can stop the video now. You can leave the video and go and watch the video after that. But if you have ultrasonic, if you don't watch the ultrasonic video yet, you can watch the previous video, which you can access it from the link down below or from up top above. If you already have watched that video, so you can directly continue with this video here, with this part of the video here. So as you can see here, we already defined constant buzzer here. So I as usual, I'm pretty lazy to rewrite everything again. So just refer to this course. So basically we have define the definition is all up top here, so just paste there. So that just paste the buzzer here, and then we set the pin mode buzzer as output. So set the pin mode buzzer as output, so just add the pin mode buzzer under the serial.begin. Okay, so and then the next part is basically nothing different. We need to check the values, and then we wants to check the pulse in, calculate the distance, and display the distance in the serial monitor. And finally, then we can we wait for about 10 milliseconds before we start to before we start to sound the alarm or check the distance. So let's say because we want the alarm to sound when the distance is less than 15, or maybe less than 12. Yeah, so let's say maybe less than 12, so that it is not directly sound the alarm. So less than 12 or maybe less than 10, I think. Try, so we just try. So if the distance is less than 10, then what we do is we start to do this coding here, which we start to give a tone of 1000. So tone 1000 and delay for 1 second. So that's it. So this is how we do that. And then if the distance is greater than 10 centimeters, so else then we no tone. We stop the tone. So that's it. So no tone. Okay, so that's it. That is the only coding. Okay, so no tone to stop, tone to sound. So and then the others are the same thing, just buzzer output. Okay, nothing else. So this is the only coding. So let's try to run this code, or maybe we can verify first while I'm connecting the. Okay, so done compiling. Let's upload it. Alright, so done uploading. So let's test the codes. As usual, to check the distance, open up the serial monitor. So now the obstacle is at the 18 centimeter, 15 centimeter, no sound yet, 12 centimeter, no sound yet, so 10 centimeter, so less than 10 centimeter, it start to sound alarm. So when I move more than 10 centimeter again, at 11, 12, 11, there is no alarm yet. Less than 10, it start to sound the alarm. Okay, screen. So maybe I make the sound clearer with my microphone here. Okay, so you can see and you can hear it clearly, hopefully. So this is how you do that. This is how you do it, how you can control, or how you can sound a buzzer, sound an alarm when the sensor value change. Just use tone and no tone function here. And for the ultrasonic sensor just now, this is how actually also how you can change the motor movement by using this if function here. If the distance is less than 10 or 20, so the motor will stop, or motor will rotate in other directions. So how to change the motor rotations, how to change the direction of the motor, all I already have explained in the previous video, in the motor video. So again, feel free to click the link up top or down below. I have already I will share the link in this video here if you want to know how to change the motor direction, which is the video from the previous video if you don't watch it yet. So that's it. That's how we do it basically for the buzzer. So the same thing for any of other simulation. Let's say I just try to rerun this in the Proteus. So Proteus, ultrasonic lecture. Right, so let's try. So distance less than 4, so it will sound the buzzer as you see. So when I increase it, so it stops the buzzer. When the value is less than 10, then it will sound the alarm. When the value is higher than 10, it will stop the alarm. So that's it. That's how you do, or how you test, or how you simulate the buzzer in the Arduino, and how you test the distance in the Proteus. And that's it. I think I did not miss anything. Again, if I miss anything, any information, as usual, don't forget, just ask me, just tell me in the comment down below if I forget anything. And if you have any questions, as usual, just ask. I will try my best to help you. And that's it from me for today. I hope this video helped, especially for your project, for any of your project, whether the project that you are working now or in the future project. This is basic concept. Later on, maybe I will do other videos that directly goes to a practical project. So if you want to know that, if you want to watch that kind of videos, or if you want to just learn electronics in general, so make sure you hit the subscribe button down below. And if you like this video, as usual, click the thumbs up button, and share this video if you think it is beneficial for a lot of people out there. And that's it from me. Thank you very much for your attention. Stay safe, stay curious, and stay joyful. My name is Ikhwan. May God bless you. Assalamualaikum.